In this lesson, we shall prove that the sine of theta equals b divided by 2a, and we've been given an isosceles triangle with two adjacent sides equal to each other. The angle b is 2 theta. The length of each side of this is actually exactly a units long, and the side opposite the angle 2 theta is actually exactly b units long. And so now to prove this in a step-by-step fashion, obviously there are a couple of ways we can prove this. And one of the easiest ways to actually prove this is actually to use what you call the law of cosines, right? So we shall have, for example, b squared, right? So b squared is a squared plus a squared minus 2a times a cosine 2 theta, which means that it is b squared, which is 2a squared, 2a squared cosine 2 theta. At this point, what then we're able to do becomes that a squared is 2a squared minus 2a squared. And so the cosine of 2 theta is 1 minus 2 sine squared theta. Right. And so we multiply through by the 2a squared, getting 2a squared minus 2a squared plus 4a squared sine squared theta, which means we have b squared. B squared is equal to 2a squared minus 2a squared. 2a squared plus 4a squared sine squared theta. Sine squared theta. At this point, we have b squared. These cancels, giving us 4a squared sine squared theta. We divide by 4a squared, both sides. And we have here exactly that. So if you divide by 4a squared, 4a squared, which means that with b squared over 4a squared is exactly the sine squared of theta. And so now what then do we have? So we have b squared over 4a squared, which equals the sine squared of theta. And what we then do is we take the square roots both sides of the equation. And so if we take the square roots, we shall have exactly the square root of b squared divided by 4a squared plus or minus, which is equal to the square root of sine squared theta, which is plus or minus. Now, this gives us b divided by 2a, which equals the sine of theta. So we have that the sine of theta is plus or minus b divided by 2a. And so if we then have that the sine of theta, we have that the sine of theta is b divided by 2a plus or minus. Yeah, it's plus or minus b divided by 2a. Right, it's plus or minus b divided by 2a. But in view of the fact that if you actually look at this particular angle 2 theta, it can be either acute or obtuse. So that if ever this angle is as large as 180 degrees, just shy of 180, maybe 120. Right, if this 2 theta is like 120 degrees, you divide it by 2, you get 60 degrees. And this makes it acute. And thus you can say the sine of theta is b divided by 2a with the sine of theta positive theta acute. Well, theta is an acute angle. Theta is actually an acute angle. Is an acute angle. Okay, or it's an acute angle. But now look, my friends, we continue with our analysis of this particular question, but it can't only be done in this way. There are other ways we can use to obviously do this question, and let's look at an alternative method. One way to do that is to say this is an isosceles triangle, and these two base angles are opposite equal sides, and they're therefore equal to each other. So, but first you can say the angle A. Let's say the angle A, the angle C is 180 degrees, which is the sum of angles of triangle. And at this pointer, these two base angles are equal to each other, so that you have the angle A, which is 180 degrees, which is 180 degrees minus 2 theta. Divide by 2, which is 90 degrees minus theta. Right, so it means therefore that you can then say, therefore, the angle A equals the angle C equals 90 degrees minus theta. So that here you can put 90 degrees minus theta, but also here you can put 90 degrees minus theta as well. And so we actually have transformed the triangle to a triangle with the two base angles determined in terms of their magnitudes. So this is 90 degrees minus theta, but also this is 90 degrees minus theta there. And so now at this pointer, we can actually be in a position to say in this particular triangle, we have b divided by the sine of 2 theta, which is a divided by the sine of 90 degrees minus theta. And so this is the same as what exactly? So it is b divided by the sine of 2 theta, which is a divided by the cosine of 2 theta, because the sine of 90 degrees minus theta reduces to this in terms of reduction formulae. At this pointer, we can actually be in a position to cross multiply, getting b cosine or theta is a the sine of 2 theta. B cosine of theta is a, and you multiply it by the following. 2 sine theta, cosine theta. 2 sine theta, cosine theta. Right, 2 sine theta, cosine theta. And so now we're able to get exactly the following. So we have, if we have this and we say we have, we can actually be in a position to simplify this. The question therefore is, how do we simplify this? So we can divide both sides of the equation by the following. We can divide both sides of the equation by, for example, right, because we want to make sine theta the subject, so we can divide by 2a cosine theta. We also divide by 2a cosine theta. All right. And so now when you do this, you then have sine theta. You then have sine theta. As a consequence, what are we then getting? We then have sine theta equals exactly what? But also, we are sure that this cancels out, and this gives us sine theta is b divided by 2a. Sine theta equals b divided by 2a. And so now we're able to get this particular result here. We're able to get this particular result. And so the couple of things we can take into account here. The method we use is called the law of sines, or you can call it what you call the sine rule. You can call it either the law of sines or the sine rule there. Right, and so we continue. And get the following. But also, in other words, you can use the law of sines to do it. But previously, we actually decided to use this law here called the law of cosines. Okay, if you don't want to call it the law of cosines, it's called the cosine rule. Cosine rule, or what you call the law of cosines. Right, and so now we have been able to prove this particular question, but also to solve it step by step. And so we are thrilled and delighted to have solved this particular question. And so until next time, take care and goodbye to you.